2025. This is the first masterclass, and it will be about optimizing balance of plant and maximizing safety in electrolyzer operation. I suspect most of you are here because you are a hydrogen producer, or you are an OEM, or you are supporting OEM. So this masterclass is going to help you by essentially being able to ask the right questions, by understanding how the balance of plant works if you're a hydrogen producer and you're looking to get your electrolyzer. And also, if you're an OEM, or if you're supporting OEMs, you'll be able to figure out how to support your customers even better than you already are supporting them. So this is the topic that we're going to talk about. So my name is Hunor, pronounce it Hunor, and I'm a mechanical engineer, and I have close to a decade of experience in PEM electrolysis. I am I'm the founder at Hydrogen Training Solutions, where obviously I do training courses on PEM electrolysis, and if you haven't seen any of my webinars, they're all free on YouTube. It's also my website, hydrogentrainingsolutions.co.uk. They're all completely free. Please do check it out. By the way, if you want to take pictures or videos, that's absolutely fine. I think you will get the slides afterwards as well, so don't worry too much about that. But I also am a co-founder at caxo.co.uk. I nicely balance my time between the two companies, and at caxo.co.uk what we've done is we spent the past 18 months designing a stack and also designing a balance of plants. So I'm not going to be regurgitating some information to you that I've read somewhere or heard. I've literally spent the past 18 months doing this, and I went through all the pains of doing this in the past 18 months. Our stack, this is our stack. It's actually over there. You can have a look afterwards. This is our stack, and it's a relatively small stack because what we think or what we're trying to achieve is, let's say one stack requires attention. Well, it's only a small stack, so only a small portion of the electrolyzer is down, and only for a few months, because every 6 months we must go on site anyway, and it will be virtually the customer virtually won't even recognize that there was a stack down, because only a tiny portion of the electrolyzer will be down. So what we will be talking about today is, first we'll have an introduction to what an electrolyzer is and what it's used for, etc. We'll look at containerized and modular, but that will be just sort of an introduction. We'll look at stack basics. We will look at the balance of plant as a whole, and then afterwards we'll look at each balance of plant individual subsystems, and after that we'll look at electrolyzer safety, and we'll look at some of the latest innovations. At the end there will be a Q&A. Please do write your questions down. If you have any questions on any particular slides, I've destroyed my slides for your sakes. I've put a number there. If you have a question on any particular slide, then please write down the number. I hate the number there. It completely destroyed my presentation, but there we go. So this is our team at caxo.co.uk. We've got Peter, who's the other co-founder, is a commercial director. He's started a lot of companies in the past. I think he started about maybe 50 different companies. Most of them are still operating, and I think north of England, there's a town called Skipton. He's the largest employer in that town. His companies employ the most people there. He started up, I think, a company called Totalize PLC, which was an internet provider. I think he sold it to BT, etc. So he's great at being a commercial director. Very happy there, probably Mont Blanc or somewhere like that. We've got Jord, who's our mechanical engineer. He's just an absolute wizard in mechanical engineering. He's got a bit of a mugshot there. I can say that because he's family, but I think we need to change that picture. And then we've got Ahmed, who's our process engineer, absolutely great at process engineering. He does process engineering and compliance for us. So let's jump into it. So what the hell is an electrolyzer? Well, an electrolyzer is an electrochemical equipment which takes water and it takes electrical power, and it uses the electrical power to split the water into its constituents, which is hydrogen and oxygen. We tend to throw away the oxygen and we keep the hydrogen. We use it to achieve net zero by 2050. So most popular electrolyzer system types are, of course, alkaline, so alkaline, just a little bit about alkaline is that alkaline was invented around 1800, depending on which date you go with. Around 1800, by 1900, there were already relatively large-scale alkaline electrolyzer plants out there. So alkaline is a mature technology by any stretch of the imagination. We also have PEM. The difference between the two is alkaline. Typically, alkaline systems use around 25 to 30% potassium hydroxide as liquid electrolyte. So it's 25 to 30% potassium hydroxide, the rest water. There's a diaphragm in the middle. And PEM, on the other hand, and of course this presentation is focused on PEM electrolysis. PEM, on the other hand, uses a membrane. So PEM stands for two things: proton exchange membrane, but PEM also stands for polymer electrolyte membrane. So the membrane is made out of a polymer material. It's a plastic membrane. It's a perfluorosulfonic acid polymer, which is a smart word, plastic membrane, and it is the electrolyte itself. So we do not need to put any liquid electrolyte into the water. So on the left-hand side we have water, and it can be just pure water, and on the right-hand side we have the hydrogen, and then we have a few other technologies, all of which are represented here at the conference. So we've got solid oxide, which takes, of course, very high temperature steam, and it doesn't only take the energy as electrical power; it takes the energy as as temperature, as heat energy, and also that will mean that it uses a relatively small amount of electrical power. We also have decoupled electrolysis, which is a not a lot of people are familiar with decoupled electrolysis. Decoupled is essentially like a redox flow battery on steroids. It uses a reactor and a redox flow battery essentially, and it's going to you can charge the redox flow battery, and later you can use the reactor to take the hydrogen out. And we also have AEM, anion exchange membrane. And anion exchange membrane is essentially a hybrid between PEM and alkaline. It uses a membrane, but it also uses 1% potassium hydroxide. Great. So what I want to show you now is on the containerized PEM electrolyzer system, we so depending on which manufacturer it's made by, the systems are going to be relatively similar, and we are going to, in general, talk about the PEM electrolyzer systems that essentially all electrolyzer systems work essentially the same way. Just like a diesel engine works in the same way, but it's made by BMW, Mercedes, and Audi, but essentially they work in the same way. So let's have a look. Air blast cooler. So it has an air blast cooler. This is an L system, obviously. Refrigerant chiller, rectifier. Water purification system is going to be inside the container. We've got the stack, which is going to be inside the container. Hydrogen water separation system, which is going to be inside the container. Oxygen water separation inside the container. Hydrogen purification system again. But this is a different system. Surely this is going to be so much different, right? No. Air blast cooler, refrigerant chiller is going to be here. Rectifier. This container is the rectifier container. We've got the water purification inside of here. Stack inside. Hydrogen, oxygen, both of the separation vessels are inside. The hydrogen purification system is going to be inside. Plug power, exact same thing. It's, well, obviously there are loads of differences, but we've got the air blast cooler, refrigerant chiller, rectifier is going to be inside. So this is the transformer, the rectifier is going to be inside. Stack, hydrogen water purification, oxygen water purification, hydrogen purification system, all inside of the container. So these were containerized systems. Let's look at the modular system. Surely this is going to be so much different. No. We've got the air blast cooler. There's an asterisk there because it's not actually on this picture. It's going to be out here somewhere. Refrigerant chiller is going to be out here somewhere. Rectifiers, 1, 2, 3, 4, 5, 6, 7, 8. These are the rectifiers and the transformers. We've got water purification system, which is going to be here somewhere. The stack, 1, 2, 3, 4, all of these are stacks. We've got the hydrogen purification system, which is, well, the hydrogen separation is going to be here. The oxygen water separation is going to be there. We've got the hydrogen purification system there. So what I'm showing you here is that they are virtually sort of very, very similar to one another. And what we'll do in this presentation, and we'll go into how a typical balancer plant works in a typical PEM electrolyzer system.